Section 3.4 Measures of Position and Outliers. In this section, we'll look at these 5 objectives. Objective 1, determine and interpret z-scores. The z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. We find it by subtracting the mean from the data value and dividing this result by the standard deviation. There's both a population z-score, we see here, and a sample z-score that we see here. And notice for the population we're using the population mean and standard deviation. For the sample we're using a sample mean and a sample standard deviation. The z-score is unitless. It has a mean of 0 and a standard deviation of 1. So let's look at an example. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7 inches. Data is based on information obtained from National Health and Examination Survey. Who is relatively taller? Kevin Garnett, whose height is 83 inches, or Candace Parker, whose height is 76 inches. In order to compare, we need to calculate the z-score. So the z-score for Kevin Garnett, we're going to take his value, which was 83, and subtract the mean for the males, which was 69.1. We'll then divide that by the standard deviation for the males, which was 2.8. And we'll get approximately a value of 4.96. So now let's find the z-score for Candace Parker. Her height is 76 inches. We'll subtract then the mean height for females, which is 63.7, and we divide that by the standard deviation for females, which was 2.7. And we see that then we get a z-score for her of 4.56. So Kevin's height is 4.96 standard deviations above the mean, and Candace's height is 4.56 standard deviations above the mean. So Kevin Garnett is relatively taller. For Objective 2, we want to interpret percentiles. The kth percentile, denoted P sub k, of a set of data is a value such that k% of the observations are less than or equal to the value. So when we see P sub 98, that means that 98% of the values are less than or equal to that. So let's look at an example. The Graduate Record Examination, or GRE, is a test required for admission to many U.S. graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than the 70th percentile for admission into their Human Genetics MPH or MS program. We want to interpret this admissions requirement. So in general, the 70th percentile is the score such that 70% of the individuals who took the exam scored worse, and 30% of the individuals' scores were better. In order to be admitted to this program, an applicant must score as high or higher than 70% of the people who take the GRE. Put another way, the individual's score must be in the top 30%. Objective 3. We want to determine and interpret quartiles. Quartiles are special percentiles. They divide data sets into fourths, or 4 equal parts. The first quartile, denoted Q sub 1, divides the bottom 25% of the data from the top 75%. Therefore, the first quartile is equivalent to the 25th percentile. The second quartile divides the bottom 50% of the data from the top 50% of the data. so that the second quartile is equivalent to the 50th percentile, which is equivalent to the median. The third quartile divides the bottom 75% of the data from the top 25%, so that the third quartile is equivalent to the 75th percentile. So here we have a visual of where the quartiles fall relative to the data. So now let's look at how to find quartiles. Step 1 is to arrange the data in ascending order. Step 2, we want to determine the median, or the second quartile, Q sub 2. Then step 3, we'll divide the data set into halves, the observations below or to the left of the median, and the observations above the median. The first quartile, Q sub 1, will be the median of the bottom half, and the third quartile, Q sub 3, is the median of the top half. So let's look at an example. Here, a group of Brigham Young University, Idaho students collected data on the speed of vehicles traveling through a construction zone on a state highway, where the posted speed was 25 miles per hour. The recorded speed of 14 randomly selected vehicles is given below. We want to find and interpret the quartiles for speed in the construction zone. Notice that the data is already in ascending order, so we can move on to step 2. Since there are 14 observations, the median, or the second quartile, is the mean of the middle two observations, which would be the 7th and 8th. So Q2 will be equal to 32 plus 33 divided by 2, or 32.5. This is also equal to the median. And notice that that has divided our data into two halves. So to find Q1, we want to find the median of the bottom half of the data. And now we have an odd number of values, so the median is going to be exactly a data set value. So Q1 will be equal to 28. And Q3 is the median of the top half. Again, it's an odd number of values, so it's exactly a data set. So we find the middle value, and we see then that Q3 is 38. So let's interpret these. 25% of the speeds are less than or equal to the first quartile, which is 28 miles per hour, and 75% of the speeds are greater than 28 miles per hour. 50% of the speeds are less than or equal to the second quartile, which was 32.5 miles per hour. So 50% of the speeds are also greater than that. And then 75% of the speeds are less than or equal to the third quartile, the 38 miles per hour, and 25% of the speeds are greater than that. In Objective 4, we want to determine and interpret the interquartile range. The interquartile range, or the IQR, is the range of the middle 50% of the observations in a data set. That is, the IQR is the difference between the third and first quartiles and is found using this formula. IQR is equal to Q3 minus Q1. So, using the data we had before of our speeds, we want to determine and interpret the interquartile range. Remember that Q1 was 28 and Q3 was 38. So the IQR is equal to Q3 minus Q1. So we have 38 minus 28, or 10. So the IQR is equal to 10. So the range of the middle 50% of the speed of cars traveling through the construction zone is 10 miles per hour. Suppose a 15th car travels through the construction zone at 100 miles per hour. How does this value impact the mean, median, standard deviation, and interquartile range? So here's what happens to our values. We see the mean, median, standard deviation, and IQR without the 15th car, so from our original set of data. That's in the first column. The second column, we see what happens to those values when we add this 15th car traveling at such a high speed. So remember when we were talking about resistant measures, the median and the IQR were not affected very much by this extra extreme value, but the mean and the standard deviation were. So those two were not resistant. However, the median and the IQR were. So based on the shape of our distribution, we can tell which measures we should report. If our distribution is symmetric, so we don't have any extreme values, then we would report the mean and the standard deviation. But if we do have extreme values and our distribution is skewed left or right, then we would report the median and the interquartile range. Objective 5. We want to check a set of data for outliers. We're going to check for outliers using quartiles, and here are our steps. Step 1, we want to determine the first and third quartiles of the data. Step 2, we compute the interquartile range. Step 3, we determine the fences, and the fences serve as cutoff points for determining outliers. We have a lower fence, which is Q1 minus 1.5 times the IQR, and a formula for our upper fence, which is Q3 plus 1.5 times the IQR. Step 4, if a data value is less than the lower fence or greater than the upper fence, it is considered an outlier. So let's look at an example. We want to check the speed data we had from our previous example for outliers. So the first step is to identify the first and third quartiles, which we did before. So we know that Q1 was 28 and Q3 was 38. The second step is to find the IQR, and we found that as well. The IQR was 10. Now we'll compute the fences. The lower fence, remember, is Q1 minus 1.5 times the IQR. So we have Q1, which was 28, minus 1.5 times 10, which was our IQR. And when we evaluate this, we get a value of 13 miles per hour for our lower fence. The upper fence is Q3 plus 1.5 times the IQR. So we have 38 plus 1.5 times 10. And this will give us a value of 53 miles per hour for our upper fence. So now we look back at our data set, and in the original data set, there were no values less than 13 miles per hour or greater than 53 miles per hour. Therefore, there are no outliers. However, if we looked at the data set where we added the 15th car going 100 miles per hour, we would see that that value, since it was greater than the 53 miles per hour, our upper fence, would be considered an outlier in that case.